Welcome to Thursday. Thank you for waking up early. I hope you have coffee. If you haven't, run now, please, and come back. I hope everybody enjoyed last night's beer, pizza, and chatting with the experts. I certainly did. And for those of you that went to the Nexenta party, I hope you guys had plenty of fun there too. I know I certainly did. Never far away from a drink. We have an exciting conversation this morning. If you look in your programs, you are at the right place. The title has changed, and I'll let the speakers explain why. But one of the things, the rationale behind changing it is, let's hear from customers. Let's hear how people actually put this stuff to good use. All right. So the title of the session now is Solving Business Challenges with Software-Defined Storage. We already had some of those debates yesterday morning for those of you that were able to join us. And so we're going to extend this. This is going to be an important topic. This is going to be a topic that is going to be discussed, debated, and diluted, unfortunately. But there's going to be a lot of talk in the next 3 to 4, 5 years about software-defined storage, software-defined data center, and software-defined practically everything. Our list of speakers is impressive. Bridget Warwick is the CMO for Nexenta. Amongst other things, she was the Vice President for Marketing at BlueWark before they sold, and actually through the acquisition by HDS. She was at Store Simple, which is now an asset of Microsoft's. So she's got a great track record, including a patent of her own on how to do whole product gap analysis. I haven't sat down with Bridget about this yet, but we're going to have a very long chat about this concept.
Thanks for the heads up.
No problem. So some of the customers, we actually have on the panel him, Steve Scherer. He spent 22 years at HP in their business critical systems before being part of Silicon Mechanics, which is a reseller based out of the Washington State area, correct?
Correct.
So welcome, and we're looking forward to talking with you. And his customer is Nicolas. He is part of INgroove, which is a media distribution and administration company. And then lastly, we're going to hear from Doug Soltesz from Van Budlines. And Doug, this is your second tour, from what I understand, of Bud Van Lines, correct?
They always ask me that.
So I think by the end of this, it'll be 10 years, so congratulations. Obviously, the second time around was equally as good as the first. But enough from me. Ladies and gentlemen, Bridget Warwick.
Thank you, Ben. Thank you. So let me take a second and talk more about why the title of this session changed. Because for those of you who have read the conference guide and some of the poster boards out there, you'll see that the track really is focused on adoption and use case when it comes to software-defined storage, open storage today. Originally, the plan was that we would kick this off with me having a conversation with Evan Powell, former CEO of Nexenta, now our Chief Strategy Officer, about how the market was trending. In the last, handful of months, just about every industry analyst has started writing, covering this phenomenon, software-defined storage. And there are precious few data points that show how far it's penetrated from a market share perspective at this point, but everyone's talking about it, and everybody's trying to define it. We heard from several of the presenters yesterday some of the parameters from a technology perspective. What is software-defined storage? But at the end of the day, when I thought about a conversation between Evan and I talking about market trends, I thought that might be fascinating for Evan and I, but frankly, from the audience perspective, I think it's much more important that we hear from customers who are already running their business on open storage, on software-defined storage. So apologies for the confusion if you came thinking that you were going to have a market trend conversation. I will touch on one or two of the market trend details before I hand over to the far more important people up here with me, which is our customers and our partner, who are, as I said, running their business today, have been running their business for quite some time. I think that open storage running in production environments with customers betting their business on that technology and the solutions built from that technology is perhaps one of the best kept secrets in storage today. Speaking purely from a Nexenta perspective, over the last 5 years, Nexenta has built a footprint of approaching an exabyte in data. Much of that production data across all our customers. And Nexenta is just one piece of this open storage movement. So there's a lot of people already doing this. And as much as the legacy vendors, storage vendors, might try to say this software-defined storage is a new thing, it's a new trend, let's define it together, or let me define it and I'll ship something in another 6 months. The truth is that real people are doing this today and have been for some time. And perhaps I'm addressing precisely the audience that knows that. I think we need to get that message out to the broader community. So before I hand over and let you listen to real people who are doing real things with software-defined storage, I do want to take a moment and talk about the market trend and the conversation at the industry level, because I think it's an interesting one. I think it marks a departure from something that is interesting but not very important to something that is changing the face of the software industry. You heard it in Tarkin's keynote yesterday, the mess of legacy vendors, right? Massively expensive storage systems. It's open storage and solutions based on it that are going to change this industry. So I am going to start with what some industry analysts say. Everybody's writing about it. If you've read an IDC report or a Gartner report recently, they've all acknowledged software-defined storage. If you're IDC, you can't possibly call it software-defined storage, though. You have to make up your own phrase, which is software-based storage, I believe. And if you're coming to the world from an OpenStack environment, I know the OpenStack folks are much more keen to talk about software-led architecture versus that phrase, software-defined storage. Frankly, it's all the same, no matter what label you put on it. It's separating the software from the hardware so that we can take advantage of the innovation in both of those worlds and bring cutting-edge technology in the form of a solution to solve the business cases of today. I chose 451 Group as the analyst to focus on just for a couple of minutes. And the quote you see up on the screen in front of you is taken from a report they published in the last 3 weeks. One of the good things about 451 Group is that over the last, I want to say, couple of years, they acquired InfoPro. InfoPro has a database of customers that they survey on a regular basis. And they survey them in a very detailed way and gain insight into how technology is changing. The adoption rate of fiber channel over Ethernet, for example. And over time, by going back to this pool of customers, paying customers who are putting their money into the trends and the changes in the storage landscape, they can build a fairly good picture of what's really going on. Never mind what the vendors say, what's really going on. And this is taken from Storage Wave 17. They've surveyed their storage folks 17 times. And I find the report interesting in light of the topic at hand. So once upon a time, I added the once upon a time bit, storage capability was dictated by hardware. Vendors made their own hardware. And they put their own chips around generic drives. If you are a customer of EMC or NetApp today, you know that they are much more interested in talking about their software than their hardware, but you can't buy those things separately. You have to buy the full bundle. And over time, they have built their own storage systems. Shopping around was necessary, as the hardware could deliver a significant difference in availability and performance, depending on how those vendors built the systems. Over time, though, the hardware differences have melted away. I mean, that phenomenon is the commoditization of hardware. So what does 451 Group think, based on interviews with their customer base? What do they think is going on now? They think that we have reached the point where software-defined storage is a reality. We just need the last few core enablers to reach software-defined. Well, if you look through those bullets, I think you'd recognize that if you were in this room yesterday, we have multiple vendors delivering those bullets today. But the very last bullet is the one that I want to highlight in this conversation, because 451 Group's customers said open source storage software is a necessary component. Not every vendor is going to deliver open source-based storage software. But from a customer perspective, 451 Group is hearing it's going to take open source-based storage software to deliver on the reality and the business benefit of software-defined storage. So let me take just a couple more moments before I open this up to real people doing real business with this technology and look at what is this software-defined storage, and what is the business benefit? We heard a lot from folks yesterday about how to build software such that it met the need, and for the most part, those vendors, those developers, we heard from several developers yesterday, are still building. They're in the process. The requirements are being articulated and they are designing to the requirements. But there is a whole host of folks that have already delivered software-defined storage, and people are building their business today. What benefit are they getting from the software-defined storage that is in the market today? So I'll go back to that mess of legacy vendors for a second. Both of the key leaders in the storage market today, EMC and NetApp, define themselves as software vendors. They deliver their software in the form of an appliance. They acknowledge that, yes, they sell you the hardware too, but they're really all about innovation in software. But if you look at the rest of this conference has talked just as much about innovation in hardware. Over the last 18 months, there's been phenomenal innovation on the hardware side, on the server side, and all this storage software has got to run on something. It runs on servers. And there's been outstanding innovation in servers. But if you look at the hardware that the legacy storage vendors are shipping today, it's not the cutting edge hardware, it's not the latest and greatest flash drives or controllers or fill in the blank. No, they look at a hardware platform, they decide on it, and by the time it gets to market into your data center, it's already aging from a hardware architecture perspective. It's certainly not cutting-edge hardware. And by the time they are ready to refresh that platform, it's getting very out of date. They've refreshed their software several times in the course of that 3 years. But clearly, they're missing out on the innovation in hardware that's going on in the industry. Software-defined storage gives you the opportunity to take advantage of innovation on the software and the hardware side. And I think the customers that I talk to, for them, that is a key reason to look at this paradigm rather than keep buying storage the way they've done it through the years. But it only works if the solutions are capable of addressing what the business needs. It's great that you can separate hardware from software. It's great that you can adopt the latest and greatest cutting-edge technology on the hardware and the software side, but there's still got to be the availability, the scalability, the manageability, the performance, all the classic criteria that you use to evaluate a storage vendor. If the solution doesn't deliver on those key areas and more, I know we've all got the standard checklist, then it's still a science project. It's still something interesting that you put in the corner of the lab because you know it's going to get there eventually and you want to educate yourself, but you're not going to run your business on it. The software-defined solutions in the market today are there from all those ilities perspective. They are highly scalable. They accommodate a variety of use cases. They may be optimized for, they may be optimizable for a given use case, but they are capable of addressing a wide range of data sets and workloads across the data center today, which is what the customers to my left are going to talk to you about, how they have selected a software-defined storage solution and how they're using it to run their business. So enough from me on market trends. I know we will hear a lot more from analysts and vendors alike trying to nail down the definition of software-defined storage. I would contend that that definition, certainly I've seen a lot of alignment in the last 24 hours at this conference, and I see in the market the way folks are using it today. I think we've already arrived, and I think we already understand just what it takes to run your business on this. The benefit being you drive down the total cost of your storage environment, but you've still got the flexibility, the performance, the manageability, all those ilities that you need in order to let it into your data center in the first place. So with that, I'm going to hand over first to Steve Scherer from Silicon Mechanics, because I keep saying software, but software has to run on hardware. And it takes the right integrator to put the software and the hardware together for a given customer's need and deliver it in the form of a solution. As a customer, you want one person to call. You want one person owning, your trusted advisor, owning the issue and working it with your vendors. Steve is one of those people, and I'm going to hand over to him and let him continue this story.
Thank you, Bridget. I won't spend too much time up here because ultimately what we really want to do is get to the customer use cases, but just a little bit about Silicon Mechanics. We're a systems integrator headquartered in Bothell, just outside of Seattle, for those of you who might not know where Bothell is. We've actually been an Nexenta business partner for going on 4 years now, and have really enjoyed the relationship. And what Bridget had said really is true, because software-defined storage as a concept is great, but what happens to you, the end user, when you decide that, okay, I want to move away from this thing that was described as mess yesterday, which I really like, the massively expensive storage subsystems. But what happens when you go out and say, I want to go open, I want to pick some software, and Nexenta looks like it's a good fit. I like ZFS, I like the functionality associated with the ZFS file system. But what do I run it on, right? I mean, what am I going to, and even if I find the right hardware that's compatible with that software, and I load it and I get it to run, what happens when I have a problem? Who do I call? And that's where we come in as an integrator. And I'm not necessarily pitching Silicon Mechanics. What we're doing is pitching the partner community. What we do as a whole, as an ecosystem, as an Nexenta partner, is come together to take this world-class enterprise software, deliver it on industry standard but certified hardware that we rigorously test. And as new things become available, one of the key things that Bridget had mentioned is we're constantly attempting or trying to stay ahead of the curve. For example, there's a new product coming out very soon from Emulex called Skyhawk that we're extremely excited about, and we're actually going to get some advanced units of those to actually begin testing on. It's an all-in-one card. It's going to do 40 gigabit. It's going to do 16 gig fiber channel. You can actually do 4 10 gig links off of the single port. So these are the types of things that we're going to be adopting into the platform as they become available, and most importantly, certifying them against the software and then delivering that to the end user as a turnkey appliance. And hopefully Nico will be able to articulate some of his experience around what it's like to be able to work with an integrator, not only in a pre-sales consulting role, but also in a post-sale support role. Not having to worry about who am I going to call when I have a problem. I'm just going to call these guys and they're going going to fix my problem. And if it needs, back-end support from Nexenta, then I'm going to look to them to engage Nexenta on my behalf. So with that said, what I'd like to do now is introduce Nico Ratineau. And Nico is the, IT director. I think you changed your title recently, Director of Systems Engineering. But anyway, Nico's the guy that put it all together. So first of all, I think it would be helpful if you could tell everybody, what does INgroove do? What's the business model?
So INgroove is basically a music distribution company. So not a lot of people have heard about us, but we are the middleman between music label and online retailers. So if you are able to get music on Amazon or iTunes, it's usually because we made it available to these online retailers. So in a nutshell, a music label will send us their latest album of their latest artist. And then from this point, when we receive it, we will make it and send it to the online retailers, so Amazon, iTunes. So every online retailers need a different metadata information, music format, and everything. So we receive the content from the music label, treat the information, and then send it to the online retailers. And so because of the business we do, we need a lot of storage. And so that's where Silicon Mechanics and Nexenta comes in for us in terms of storage need.
Yeah, and when we first met, and INgroove has been a customer of Silicon Mechanics for quite some time.
Yes.
Buying, just all the way back to just hardware RAID, right? I mean, there were some hardware RAID subsystems, some, but they were migrating towards some open server architectures. But when we first met Nico and just started talking about storage a little over a year ago, they were a true mess.
Yes, exactly.
They were an IBM XIV shop with some NetApp front end, IBM blade centers, some very, very expensive infrastructure. And the conversations first centered around Gluster, I think, right? We were talking about, so talk a little bit about what the driving force behind that was.
So what happened is we started as a small company, and back in I would say back in the day, for the software-defined storage, that really did not exist, and so we went with a MES system from NetApp and IBM. And so as we grew, we realized that as a medium-sized company, because we are not a big-sized company like Bank of America, for example, or any other type of company that can afford to get big storage system, we needed something that will drive our cost down by a lot to continue to make actually profit. And that's really when the discussion started to happen, because we even were using Windows storage server as a back end to try to lower costs down by building our own cluster system. And so it was not a true scale-out system, and so that's really when we started to look at what was out there. So we looked at Gluster FS, we looked at even build maybe something on our own, and we've also discovered Nexenta, and so that's when a partner like Silicon Mechanics come handy, because usually when you work with a partner, they know pretty well your system, and so they can tell you, all right, this is what you have, but then this is what is available now, and they presented us Nexenta from their experience doing business with us. And that was really the key point here, is that they knew already what we had in the past, even if it was IBM and NetApp product, and that's what drove us to work with Silicon Mechanics.
Thanks. Yeah, and the NetApp IBM N series, and it's actually back-ended by some very large and very expensive IBM XIV systems, which frankly are very good. I'm not ever going to stand in front of a customer who's bought a NetApp or an XIV and say that it's not a quality product. But the fact of the matter is that we're able to do what those systems are doing at a fraction of the cost. I think I've heard numbers that you've thrown around where you've ran out some numbers about what the cost savings are today.
Yes. So if we compare, so talking about number NetApp and IBM XIV solution versus Nexenta and Silicon Mechanics Super Macro solution, we were up to 70% cost down in terms of actual usable space. Because we talk about a lot of raw space, but at the end it's the usable space that is the real number here. And so we drove our cost by 70%, 30% down, and so.
Yeah, and what I'd like to do now is we had Nico was good enough to put together an architectural overview. This doesn't include the legacy stuff. This is basically everything that we've implemented just within the past year. So that's the other thing that's been really exciting is that we've been able to move this into production, and this is this is tier one. This is not just we didn't just put in an archive solution that basically is a backup target. That's tier 3 type hardware. This is running tier 1 production data. So what I'm going to do is I'm going to let Nico talk a little bit about and step you through his diagram that he's put together. Basically, we're implementing our 4th system that's going into Dallas, and we're going to do DR to the 3 systems that exist right now in San Francisco, and I'll let you kind of step everybody through the architecture and how it's evolved.
So yes, briefly, so we use NetApp and IBM XIV in the past because we have legacy application. And the key here for us was to be able to continue to run those legacy applications, but then also move forward with new technology like software-defined storage, but the SDN and the compute processing and building the environment that we need to be really the key agile, because we are really going into the IT being a service for the rest of the company. And what we really tried to do in the first place was actually put the cost down quite a lot. And so in actually even less than a year, we've deployed quite a lot of Nexenta to replace our environment with NetApp and IBM. And so the data center one is actually our main active colo station. That's where we run the actual business. And so the key for us was to really find and deploy a system that where we will be able to store the music content, because we are a music digital company and we need to store music, metadata information, jackets, and all of that. And music business, usually you get content, but you never, delete any content, because you artists create new music, but you still sell some Elvis Presley, for example, Michael Jackson music, and so we keep getting content as we get more labels. So the business is trying to get more label on one side, so we need to be able to continuously ingest data. And so the goal for us was to really find a solution that was incremental cost. Because when you get a system like IBM XIV, NetApp, or whatever other monolithic big system you have, usually you need to follow the directive. It's like, you need to at least get this amount of data. So let's say 160 terabytes all at once, because that's the way it is, that's the way the system is. And you cannot just say, but I just need like a couple of terabytes because it's a small label that is sending me all its content. And so the advantage of a system like Nexenta was to really put incremental cost, so where we just plug hard drive if we need to, and we have just a few hundred or just a 10 terabyte solution available. And that was one of the driving point for us also, is really being able to run on whatever we need and add storage space as we need. And so the advantage of Nexenta here for us was to really be able to run our legacy application, which is at the bottom on the data center one, which pretty much run out of CIF. So it's our application that get the music and encode all this music was actually running out of CIF, because in the past that was what we mainly do, and because also we have users that still need to access this content, those music, to listen to it and make sure it is good quality. And because of that, we were trying to find a system that will allow us to run the legacy application, but then also build our own private cloud to really give a service. And so that's when Nexenta came in, and we were able on one system pretty much do all at once. So NFS, fiber channel, and CIF, because with system like IBM or ISON, EMC, usually in the past you had one protocol, and then if you need to deploy multiple protocols, you need to buy the license. Or you want to deploy more than one or four volume, you need to buy the license to add multiple volume to multiple hosts. And so it was really like, oh, you were locked in, you need a features, you need to pay for it. You need a management tools, you need to pay for it. And with Nexenta, we were able to just install it pretty much, and then you can do whatever you want. It's really just a turnkey solution where I want to do FC, I want to do NFS, I want to do CIF, I want to do WebDAV, FTP. It's there. You just enable it, create what you want, and you're good to go. And so that was really what drove us to do that. And the advantage is on one cluster, you can really build the solution you want in terms of speed, I/O. So virtualization, usually you will need a lot of IOPS versus tier 2 or tier 3, where your IOPS are really low. And with the solution with Nexenta, you will be able to choose I need like 3 terabyte drive, or I need a 15 RPM drive. And so in one system, you'll be able to plug multiple hard drive to really decide where you want to go, and without the need of, oh, I need to buy a system from IBM where I'll just do low-cost storage, and then I need database storage, or I need a virtualization system. Then that was the main driving point. So we have 3 systems now deployed in San Francisco, actually, that do all our need in terms of storage for music content, and then we have also systems that support our private cloud that we are deploying. And now what we are trying to, we are actually building it right now, and Bud will go further into it, is our disaster recovery through auto-sync replication that comes also with Nexenta, which allow us to replicate all the data from actually multiple systems to a DR side, because the main point is always to drive costs down, and the advantage is you have multiple systems on one side, and the DR usually is much smaller. You really try to save cost, and that's where a system where it's open and use ZFS technology can replicate easily to one system to do all of that. And so the advantage again is that on the DR you can run out everything from one system, NFS, fiber channel, and CIF, and virtualization, legacy application can run from that. And so that's the advantage, is software-defined storage allow you to really do that and not focus on the hardware itself, where in the past you will just, oh yeah, I need to get one IBM XIV, it's 160 terabyte for some, and that's it. It's a full rack, you're stuck with it, and you want to get more space. Well, I can get half of one or something like that, but it's still a full rack that you need to find the space in your data center. It's just, oh, I need 10 or 16 terabyte. I'll just plug drive, or I'd scale out 1 or 2 node, and that's it. And so that's the advantage of a software-defined solution, where you just don't care about the hardware. So we work with silicon mechanics, but you can build your own, like Bud will explain. And so it's really like up to you after what you want to do. It's really open to anything. So that's one of the key points here.
Thanks, Nico. And just to reiterate, the top system, the initial system that originally was deployed as 100 terabytes usable, and then shortly after it was deployed, we added another 134 terabytes to that system. And again, not trying to make it marketing speak, but just people in here are probably trying to figure out, okay, what does that run? But 134 terabytes usable is about $52,000. So if you do evaluate a cost per terabyte, that's pretty good. You're not going to add 134 terabytes to an IBM XIB for $52,000. And then beyond that, and now we just grew it again by another 67 terabytes.
So yeah, total right now we are about half a petabyte of actual usable space.
Yeah, so we're just shy of a petabyte raw, and just shy of a petabyte raw, about almost 500 terabytes usable. And again, at the end of the day, usable is what really matters, right? I mean, we have the ability to deploy exactly what's right for the right application. The initial deployment at the top was dual parity RAID Z2. Less disks, less licensing, lower cost, more of a sequential workload, right? So what we did is evaluate, and that's what we do as an integrator, is work with the customer to define workload, right? So what is it that you're trying to accomplish? We don't want to ever do a deep dive, bag dive, if you call it, on technology, although we love to talk about ZFS, but ultimately what we really want to do is find out what's the business requirements behind your storage, right? What's driving the need? And then what we do then is we take the opportunity to say, how can we deliver this in the lowest cost, but also the highest performance, right? Again, the right solution for the need. And what we can do is we can build pools of disks, right, based on different metrics. We can do RAID Z2 dual parity again, which was the initial deployment. The virtualization server that's actually hosting the private cloud environment, the Zen cloud environment, is 15,000 RPM mirrored pairs, 600 gig, 15K drives, for extremely high IOP and throughput, where we're utilizing read and write cache and some of the benefits that are inherent to ZFS. So anyway, enough out of me, but what we really wanted to do is just make sure that everybody understands the ease of which you can expand this environment and how flexible it is. And basically we can scale out by just adding pools of disks and adding to our cluster, making it highly available and delivering a true 5 nines or better availability to the end user, just like you would with your NetApps or some of your more traditional storage vendors. So that's enough for me. And I think now, Bridget?
Well, I think it's time for
Doug.
It's time for Doug.
Can I have the clicker? Oh, it's over here.
Yes, the click's right there. Let me put you onto your screen.
Okay. Hi, everyone. I'm Doug Soltesz from Bud Van Lines. Bud Van Lines is a nationwide moving and storage company, and today I'd like to talk to you about being able to do disaster recovery on a budget. So we do software-defined everything, right? We run VMware to virtualize our guests. We do that on commodity hardware. So, I'm not running Dell or IBM or HP or anything like that. Go over to the open server people. I'm using their hardware. For our storage, we're running ZFS mainly for our VMware environment through Nexenta on, again, commodity-based hardware. And for our end users to connect into our system, we're using Citrix. And you're going to go, well, Citrix is not open. Well, no, it's not, but it is still software. It enables commodity devices. It enables commodity devices to connect my end users to their environment. So you can pull out your iPad, I can pull out my phone, you can have your laptop or your Chromebook, and I can allow my users to access our environment from anywhere using this software-defined everything environment. So a couple of quick things. I'm not going to be able to tell you everything there is about disaster recovery in the next 35 minutes. I wish I could, but it'd be a whole day conference. I have a ton of links because there are so many different ways to do this, and I'm not going to be saying, VMware every other sentence or Nexenta every other sentence. There's a lot of people out there that allow you to do things through commodity. And if you want these slides, it's really simple. I'll tweet them afterwards. Go to doubleparity.com. I created a blog site this weekend, and this is the only thing up there. If you take down that address, it'll take you straight to these slides. And my last note is, hey, sometimes you do get what you pay for. So when I start talking later on, can you do disaster recovery on a budget? Can you build your own SAN for $100 buying parts on eBay or getting SATA drives? Yes. But you know what? You might not get support. You might have should have spent the extra, few $1,000s to call Silicon Mechanics. You're still doing software-defined everything, but you know what? It depends on your resources. Now, I will say, doing everything yourself will give you a lot more expertise in the marketplace. So why is Bud Van Lines an expert on disaster recovery? Well, because we've learned through experience, right? We're headquartered in New Jersey. We've had 2 hurricanes in the last year, 2-foot snowstorm in October. The trees didn't understand that they were supposed to have lost their leaves ahead of time. It just seemed like every other week we had no power for a week. We do have offices nationwide. I have them in California. I have them in Ohio, in Georgia. They're prone to tornadoes, floods, gas outages. So, you'd think that, some of my sites are okay. Well, I can tell you that after Hurricane Katrina, I had to fly down to our Atlanta office. Around the same time, there was a tornado spurned off from the aftermath of Hurricane Katrina. So not only was I down there to check the damages from a possible tornado hit, but there was no gas anywhere. I'm very sorry. There was no gas anywhere to be found because all the refineries were shut down. All right, so I'm not going to say you can do it in 4 easy steps. I'm going to say you can do disaster recovery in 4 steps. And the first step is virtualizing your environment. Then you need to replicate your data to another site. You need to automate this data, and you need to allow your users to communicate and get back into your system. And again, none of these steps are easy, but this is what you need to do. So the first thing is virtualization. Now, is anybody here not virtualizing their environment at current? Is this like a new word for anybody? So good. I built this slide myself. This is like my one animation I'm very proud of. Thank you. What I'm trying to show here is, hey, you need virtualization in order to have disaster recovery. And you need virtualization because it allows you to move a server, a virtual machine, this packetized object container from one set of systems to another. Now, this could be in your own data center. So disaster recovery starts at home. It starts in your core. If I've got a bunch of hosts and they're all running along and one of them has bad memory, I can live vMotion VMs from one server to another. All of my hand-me-down servers go to my California office, which is currently our disaster recovery site, and I can power off a VM, and even though I have Intel in one spot and AMD in the other spot, I can migrate them all over what's called cold, meaning they had to be shut down first, and we can recover from that. So let me talk about the first step. If you're trying to do hypervisors on a budget, well, you can't really do VMware on a budget. So VMware does have a free product, and we are a VMware shop, and we do pay them a good amount of money, but it's kind of worth it. And again, I am using software defined because this is software allowing me to have my guests running on commodity hardware. VMware has a free edition, but if you try to use their free edition to do disaster recovery, you're going to be really disappointed. What happens is they lock out all the API commands to do things like shut off your VMs, etc. They also don't give out a free management console. So when you talk about using hypervisors or virtualization to do disaster recovery, you need to have 2 things. You have to have your hypervisor. That's where all of your VMs are going to run. You also need your centralized management. You could do it by trying to pull all the hosts, but if you've got 100 hosts or 10 hosts, you're going to pull your hair out. You need something like Virtual Center from VMware. You need something like Zen Server, Zen Center. You need that centralized management because you want to send commands to that centralized management that says, shut down my VMs, unmap the storage, move it over to another spot. I guess just a quick question. How many people here are using VMware as the primary hypervisor? Okay. So it has a great API and all library, and we're going to get into that in a minute. If you're not using it, how many people are using Hyper-V? Okay, good. I don't know that much about Hyper-V. I've used it a couple of different times. The nice thing is it is sort of free. Where they hit you is on the management. They hit you on the management because you've got to buy System Center, and System Center is the way that Microsoft wants you to manage all of those free hypervisors they gave you. The good news is in the free hypervisors, PowerShell works against all of them, and there are a bunch of third-party companies that will give you a free management console. So you can do Hyper-V, technically on a budget. You can definitely do Zen, and now Zen has XCP, which is their Zen cloud platform. A lot of people don't seem to know, but Citrix had acquired Zen Server from the UK. They were the first company that came out with Zen and then commercialized a product. It is now completely open sourced. If you're trying to do it on a budget, this is an excellent option. You can go to zenserver.org, you can go to citrix.org, you can download their entire hypervisor platform, including Zen Center, which is a Windows GUI-based management appliance. If you don't want to use Windows, then great. I gave a couple of links down below so that you can get Linux-based management appliances for Zen to automate the whole thing. And if you want to pay money, because again, sometimes you get what you pay for, you can call Citrix still and just pay for support. Just like with KVM, you can pay Red Hat for support. Anybody using KVM? Okay, so again, a lot of different options there. They probably have the most options. Red Hat's the big supporter of them now with, I'm sorry, our friends at Joyent using Smart OS. Okay, so you've virtualized, and virtualization, we've already said, is the first step. Why is it the first step? Because if you're not virtualized, you're not going to be able to get these VMs moving from site A to site B, or even to have that high level of redundancy in your data center. When you virtualize, you gain a couple of other things. Going on to our next step is going to be shared storage. So shared storage should be more redundant, should be more powerful than having local storage actually in your servers. You've got RAID, you've got HA, you've got clusters, you've got all this great technology, along with virtualizing your network. So I know that was a couple of topics here, but we have this very expensive HP switch that has 2 controllers and should never go down, and yet it goes down. So, when you virtualize, you can virtualize your network stack. You can have a Cisco switch sitting below it, or an Arista switch, or whatever you like, and you're able to quickly move things around, or even have the hypervisor do that automatically for you because it's doing everything with virtual NICs. Whereas if you're trying to do this without virtualization, you'd be in there trying to move a lot of wires, which is not humanly possible. So step 2 is to replicate. And when you replicate, you're going to need a second data center. I mean, whether that's in the cloud, a branch, or a co-location, you're going to need that. You're going to need data access to it. You can do it very inexpensively through VPN tunnels. That's what we're doing. We're doing IPsec over the internet, cable modems, and make sure you get static IPs. That's a huge problem. And then you're going to need to copy your critical VMs, and you need to have a conversation with your management as to which VMs are really critical, because everybody thinks everything is absolutely critical. Where you send your data is really up to you. For Bud Van Lines, because we're nationwide, it made the most sense for us to deploy a second Nexenta system in our branch offices that we could replicate the data to. If you don't have branch offices, maybe co-location makes sense for you, but some of the cheapest prices I found for a single rack was $12,000 per year. I don't know how that fits into different people's budgets. The cloud is interesting. The cloud kind of has a break-even point below 10 terabytes because you got to put your data up in the cloud, and some of the cloud prices are about $100 per terabyte per month. So if you've got 10 terabytes, you're paying $1,000 a month, times 12 months, you've got your $12,000 again. But you're only paying for compute when you actually spin up your environment. So however you do it, that's totally up to you. But the point is, you need a secondary site. There are 2 different ways to get your data over to the other site. So every backup provider is going to sell you something called VM-based replication. It's included with Zen, it's included with VMware. They're going to take your VM, they're going to snapshot it, they're going to move it from site A to site B. Well, the problems with using VMware-based replication is it's hard to get a very low RPO, and RPO is your incredibly point objective. So at Bud, my management has said, Doug, we really want to make sure that if Bud goes down, that the data sitting in California is no older than 15 minutes. Well, gee, that's pretty hard to do if you're constantly snapshotting VMs, running everything independently. The way we do it is SAN to SAN replication, which is made affordable by open source technology, ZFS, Nexenta. SAN to SAN replication has the problem that you're taking this snapshot of a virtual machine, and the virtual machine does not know you took a snapshot of it. And what can happen is you get this thing called a crash consistent image, whereas on the top level, you're not crash consistent. The virtual machine knows you're taking a snapshot of it. On the top level, if you're not using VMware, you got to watch out for this thing called leaf coalesce. What happens is the other hypervisors, they take these snapshots, they do their backup, they replicate it to the other side. You tell Hyper-V, okay, get rid of that snapshot. He goes, no problem, I got rid of that snapshot. You look on the actual storage and the snapshot's still there, and you go, what gives? And then after like 3 months of running your software, you have 90 snapshots sitting out there, and your whole SAN, fills up and crashes. it's a leaf coalesce problem. So you need to watch out for that if you're going to try to do the VM-based replication. I'm going to talk today about SAN-based replication because I think that that's the future. I think that's the only way that you can really meet your recovery time objectives. And we use ZFS, and we think ZFS is great. Obviously, there's open ZFS, and the only issue with ZFS is, how do you do ZFS in a production environment? Because you want to make sure that it's certified. I don't want to run something that VMware is not going to certify. Well, that's where Nexenta comes in. I want something that's HA, where if one of my nodes goes down or Nexenta sends me out a patch I have to put on, I want to make sure my entire environment is still running. Nexenta, has HA. You can go to RSF and get HA from them. There's a competitor called TrueNAS that has HA. Why did Bud Van Lines choose Nexenta? Well, because Nexenta is on the VMware HCL list, and that matters a lot to us. Plus, our production VMs, we want to put on storage that has HA and support by VMware. If you want it completely free, which in a couple of cases we do. So I have these video camera systems. They write hundreds and hundreds of terabytes of data, and we want that to be extremely cheap. Well, we installed OmniOS, or go get FreeBSD or FreeNAS or any of these other ones that actually run ZFS. I know a lot of the guys yesterday talked about ZFS on Linux, etc. If you do something like that, there's this free download called NapIt, completely free, gives you this high-level management of ZFS. I know that obviously they'd love me to be saying Nexenta, but maybe for your tier 1 data you're using Nexenta, and for your tier 3 data like me, your backup, everything else, you're still using ZFS. It's free, it's on commodity hardware, and you're using these people's free tools to run with it. This is the SAN we built. I'm not going to spend any time on this slide. I just put it in case people want to go see my slide deck. Everybody was always like, oh, what's your recipe? What did you do? But kind of like Silicon Mechanics was saying, we saved a significant amount of money. I mean, it's like a quarter of the cost of what we had previously from NetApp and from Compellent. My quick notes, if you actually do build your own SAN, which I'm going to kind of recommend again, so I'm going to recommend you use a third-party integrator, because again, they're certifying the parts, they're doing all the work, they're doing everything for you. You're not going to save that much more money. Sometimes you get what you pay for, but use SAS over SATA. Don't buy parts on eBay. Make sure that you got the HCL list. I can't tell you how many people I go to dinner with, and I tell them, you should use Nexenta, you should this, you should that, and they say, I went on eBay and there's this JBot I can get, and I'm like, why do you think it's on eBay? If it's working perfectly fine, yeah. And do you really want to put your job on the line, your tier 1 data? Maybe that's my video system and I don't care, fine. Or that's my test system, fine, but not my production stuff. All right, so this is the last and most important part. Well, not really the last part. Part 4 is communicate. But I've got my data. My data is virtualized. I've replicated it to another site. Am I done? That's what all the backup vendors are going to tell you. They're going to tell you you're done. You call Nexenta, they're like, yep, you're done. You've got your data living in another site. You're not done. Has anybody ever had to fail over to another site? You got all your data there. The VMs are there. Well, what about re-IPing them? How do you spin them up? In what order do you spin them up? These questions. How do I re-register with DNS, NAT? There's all these questions, and everyone goes, well, what you need is a runbook, and I agree. What you need is a runbook, and if you don't know what a runbook is, I gave you a nice link to a wiki there. The only software that I really know of that completely automates the whole thing is VMware's SRM, which is not cheap. And the other problem with SRM is you need to have your storage provider write an SRA for it, and guess what? ZFS doesn't have an SRA for VMware. You need those millions of dollars that MES has in order to have your SRA. So how do we replicate? How do we do it? Well, on our site, I've been given authority to later on put up our PowerShell scripts. We're using PowerShell against VMware. We're using plink against Nexenta to script and failover. You don't have to be a programmer. This is easy stuff. What you do is you write a runbook, and here's a quick example of a runbook. This is from our runbook, but summarized a little easier. And then you're just saying script this. You're going to first start your replication to the other site. Why would you start your replication first? Well, because a disaster's coming, a flood's coming up the road, a tornado's on its way. You might as well start getting your data to the other site, because odds are if your power or your internet line goes down, you may not have time to clean everything up and then replicate. So first you start replicating, because I'd rather have a crash consistent copy at my other site than have nothing, at all. Then you're going to power off your critical VMs. You're going to unregister your critical VMs. Why? Well, because later on you got to unmap your LUNs from your host, because once I get everything to the other site, I want to start replicating back to New Jersey. So I'm going to power everything down in New Jersey. I'm going to replicate it all to California. The last step before I turn anything on in California is to replicate again, because if all my VMs are off, well, now I don't have to worry about crash consistency. They've all powered down properly. I start spinning up in California. Well, guess what? If that tornado misses us and it's Monday afternoon and we failed over to California, we will not be failing back from California until Saturday, because failover requires downtime. There's no if, and, or but about that. That's your RTO, your recovery time objective. How long does it take you to fail over to the other site? For us, it's a few hours. It's like 3 hours, even automated and whatnot, because of replication, because of all these other objects. So if we fail over to California, we need the replication to reverse itself, because a lot of data is going to get built up from Tuesday to Friday, and I don't want to try to re-replicate all that on Saturday. I want it to be, kicking back. And God forbid the tornado is coming up the street in New Jersey, and I replicate to California, and then like the next day the tornado misses us, but the next day there's an earthquake in California and I have to come back. Then I might as well just go to the bar. All right, so how do you replicate your failover when the only product out there that I really think that is worth paying for is SRM, and you can't do it with the Nexenta and everything? Well, you're going to use a VM over at your DR site. You're either going to create a Windows VM or a Linux VM. If you create a Windows VM and you're using Hyper-V or VMware, you're going to probably use PowerShell commands against it. That's what we're doing. You want this VM to be in your DR site, because that's the site that's supposed to live when your main site goes down. It makes no use to have this in your primary site. You have to have this VM running and scheduling things from the other site. You're going to write your scripts that say, shut down all VMs that start with the letter D, or all the ones in this folder. And again, later on, I've been authorized by my company to put all of our PowerShell scripts, once I clean them up and take our IP addresses out of it and put your IP address here on that double parity website. You can also do this through Linux. If you like Linux, you're using KVM, you're using Zen. You can automate your failover through Shell, Python, etc. So I've given you just a couple of examples with VMware from our runbooks down below. So if you want to know how to do it through PowerCLI, which is their PowerShell, there's the link that gives you every single PowerShell command. If you want to do it through vCLI or through Perl, because VMware gives you this free VMA, which is a Linux appliance that you can run everything from. The top command here, like if you want to unmount your NFS data store, because we use NFS through our open storage, the top command is how to do it with PowerShell. The bottom command is how to do it with the VMware CLI. And again, if you want these slides, they're all online, so don't bother writing this all down. If you're not using VMware, here are the different links you'll need to do the same thing with Hyper-V and KVM to run these things against Nexenta, because they have their own kind of console shell when you go into it, or how to do it against a pure Lumos-based ZFS system, or BSD-based. All right, so last step, I've got my data. I moved it all over to the other site. I powered it all up. Am I done? No, you're not done. And that's what we ran into, during one of the last hurricanes. In Hurricane Sandy, so many of our users had no power at their house. So on Monday when the hurricane was coming in, nobody came into work. Everybody Citrixed in, worked remotely from home. But then on Wednesday, everything's up and running and nobody's in the system. Nobody can make it in because of the roads, danger, everything like that, no gas. And all of our users have no power at their house, and we were surprised by the number of end users we have that don't have laptops. So we actually this year started building these disaster readiness kits, which were a Chromebook, which is like $200, a MiFi, which T-Mobile now give you like 200 megs a month for free. It was like some announcement yesterday, but we got a whole bunch of MiFi devices, which any carrier will give you for free, and you put them on like a $5 plan unless you actually have a disaster. In a car inverter, so that for $300, we've got these disaster readiness kits. We went to HR, we said, who are labeled critical employees? There were like 40 of them, and we gave them all a disaster readiness kit, because you've got your VMs running at another site, you re-IP'd everything, but how do you get your end users to connect to that? So maybe for you, that's going to be a VPN tunnel or something like that. The other thing to note is during Hurricane Sandy, we were surprised by the number of people. We shouldn't have been surprised because you have to send announcements all the time out for this. But if your website's down because you're failing over to the other site, because remember I told you to shut down all your VMs before you fail over to the other site, well, how do you tell everybody not to come into work that day? Use Facebook, use LinkedIn, make sure the employees know that you will post a status to Facebook that they can use from their cell phone to see if the company's open, if, God forbid, all of your sites, are down because you're in the middle of a failover to your other site. Forward your office lines. There's so much more, that you need to do. You can use OpenVPN if you insist on using desktops in your office instead of thin clients and VDI. And if you use VDI, obviously there's Citrix, there's Remote Desktop, there's VMware has a product called View. All those things are going to allow you to, again, software defined, break the link between that computer at the person's desk and the ability for somebody to use any device and access their compute resources. And that's all. That's 20 minutes of try to DR your environment.
That's great. Thank you very much. We'd like to open it up for general questions now. I think, is this microphone on? Yes, it is. Questions, comments, thoughts? Yes, Chandra.
A couple of questions. First of all, thanks for sharing your experience. Clearly, there's a huge cost savings, and I see the flexibility in the ZFS-based solution to tune into your application needs. Did you miss out anything moving from the MES in terms of field reviews or product quality? That's one question. And after you answer that, are you a special type of user, like geeky kind of people who can play with this open source type of stuff? Or, is this kind of solution good for most of the data centers out there, or is it a class of data centers where these solutions are a better fit?
So, I definitely encourage all end users to know the product that they're working with. So when we had a NetApp SAN, I went to the NetApp classes. When I had a Compellent SAN, I went to the Compellent classes. When I had I currently have a Nexenta SAN, so I went to the Nexenta classes. I think you have to know your equipment. I definitely think that the bigger companies, the MES, they clearly have more training classes. They probably have, prettier notebooks. Their GUI looks a little bit nicer. But at the end of the day, the ZFS core is very strong. Their core is very strong as well. You're saving a lot of money, but it doesn't look as nice. It's the difference between a Mercedes and a Honda. They're both reliable. They're both going to get you there. One of them costs 3 times as much and looks a lot prettier, and the leather might feel a little nicer on your butt. But they're both going to work. So I don't think you have to be a special class, but I do definitely believe that no matter what SAN you have, I push responsibility in knowing your equipment. And I know a lot of network administrators that have NetApp or whatever have no idea how it works because some third party came in, and they've got such an infrastructure that you don't even have to know your environment. There's a third party you can pay to do absolutely everything. And if that's you and you've got that kind of money to throw around, good for you, but we don't.
Yeah, and your point is true, is that we were in this situation where we had a solution with NetApp and IBM that was sold by a third party, and we were in a state where we did not know much of how it was working, and we know the basics. We had a GUI, nice GUI, and that was working. But then at the end of the day, when you want to really put your costs down and everything, you need to know more about your system. And so that's where open source solutions comes in. And also what you were saying about, geeky kind of person or anything, but that's where an integrator is one of the key for us, where sometimes you don't necessarily also have the money to be able to test a true system. Where let's say, I want to test a system with actual 50 terabyte or 100 terabyte of data and see how that plays out. And so Silicon Mechanics was able to put a system in their lab for us to actually do testing and play with it. And so that's really the key, where you get a feel for it, and being able to even just download the software and play on just one new server or something to get the feel for it without spending any money, pretty much, and without signing signing anything. And so you always have, you always need to look further and see what is out there to be able to change your path and do things. But yes, like he said, the GUI may be nicer, but at the end of the day, if you need CIF or you need NFS, the protocol out there, it's standard, and that's there and that's working. And so you may need to work a little bit more with the GUI, with the CLI or stuff like that. But at the end of the day, CIF, NFS, or fiber channel, it's there and that's working.
And just to add to that a little bit, we have different types of customers, and the ones that we have that run the smoothest are the ones, honestly, that don't do anything without talking to us first, which is exactly what we encourage. Our mission to the end user is to look just like NetApp. That's our role as an integrator, is to deliver a turnkey appliance, where your job, as we say, your job is to write to it and read from it, and our job is to make sure it's available when you want to write to it and read from it. And that's where we come in. And there's training and education. We do a complete turnkey service when we set it up. We can do it remotely. We do it on site. We do training. And at the end of the day, it's just a storage subsystem that's talking over some protocol, right? And if you're familiar with protocols, you're familiar with NFS and NFS style permissions and ACLs, it's no different. It's going to be the same type of environment that you're used to if you're setting up ACLs and permissions and things like that over CIFs and NFS on any other platform that's multi-protocol, that has both file and block.
And just to reiterate on what he said, again, I got to tell you, we didn't trust Nexenta when we first met them. It sounded too good to be true. I met them at VMworld. They were running the labs. Some other big player in the labs went down, and they kicked in and helped the labs run. And it's like, okay, so you've got all the performance at a quarter of the price. I don't really believe you. Well, you can go to their website. You can download the software. You can run it in a VM. We definitely did that. They have a community edition. Download it. Take an old PC that you've got at home that will work, and put all of your kids' photos and your MP3s on it. Doing things like that will teach you how to use the language. Just like people go, oh, well, Mac's easier than Windows. Well, I've got them both. If you know Windows is easier. If you want to learn Mac, then grab a Mac laptop and make that your only laptop for a week, and you'll know Mac by the end of the week, or vice versa. So, by using it, you're going to know it. So if you're afraid to present this to your boss, you know what? Build a community edition for home, and in storing all of your photos or whatever you like at home, you're going to learn Nexenta. And if you don't want Nexenta, then go ahead and grab OmniOS or whatever. By using it, you'll know it. And then if you want to make sure that you've got the I's dotted and the T's crossed, go to the integrator at the end. Silicon Mechanics, have them sell you the system, and you've got the training, the familiarity from doing it purely open.
Yeah, that's so interesting that you mentioned that, because I can't tell you how many of our end user customers started out with an advocate inside the company that did exactly that. They built a home NAS, they put files and videos on it, they stored their music library, and they got comfortable with it, and then they became an advocate for it inside the company. They said, something, this can do a whole lot more than just store pictures and movies and things like that around the home. So it's a lot of users, a lot of systems that we've sold have come to us that way, where just somebody in IT became an advocate inside the company.
Or those home NASs make their way to the office and become mission critical.
There you go.
Well,
that's right.
I got to say, that's
my home NAS is more mission critical than his. I'll tell you that right now.
But I do have to say, and I'm not obviously advocating any software piracy or anything, but the home NAS that you have, you can do a send receive. So if you start putting actual critical data on it, and then you realize you got in over your head, ZFS has send receive. You can go to Silicon Mechanics, buy a real NAS that's saying have the right performance, do a send receive, and now your data's over there, and you're out of that hotspot. The other great thing with ZFS is the pool is independent of everything else. So, if right now something happened and my controllers got knocked out and my disks were okay, I can take those disks to a different head running BSD, running all these other things, and import my pool. There's a lot of, hey, you build a home system and you shouldn't, but for whatever reason you put something critical production on it, there are ways out. But if you were talking to a mess vendor, there's probably not a way out. without a lot of money or competition. Yeah.
That's another really cool thing about ZFS that you can pull disks out of a ZFS system in no particular order. You don't have to label. You don't have to do anything. Try that with a hardware RAID setup or another vendor. I mean, you can just pull out. You got 50 disk drives. You can pull out. And those 50 disk drives might represent 3 different pools. You can just pull them all out. In no particular order, shuffle them if you like.
Put them back in.
And put them back in another ZFS system, and it will automatically recognize those disks as part of a pool, and it's a simple one click from the GUI that says import. You just import that pool.
And we tested that before we purchased. We tested for at least 6 months before we purchased.
We have a question over there. Yeah, back.
Yeah, so in your experience as an integrator or even from individual companies, you guys find that the choice to go with a traditional SAN vendor versus an open solution is more based around the risk aversion and the IT operating shop that's been running?
Yeah, I absolutely, and I think that. But back to what our Doug was saying is that the best thing to do, and what set a lot of people's minds at ease, is experimenting with it first, either at home or in the office. There is a download, a free download. It's a 45-day trial. It's the full product. It's not some scaled down version. We've actually extended trials for customers that are really serious and say, hey, we're coming to the end of our trial and we want to extend a little bit further. We say, no problem, we'll extend it for another 45 days. Really, that gets over a lot of that risk adverseness, right? Because at the end of the day, it really isn't just about saving money. Everybody says, what's the value add of this particular solution? And I say, sure, there's money savings, right? But at the end of the day, back what Bridget was talking about, if you remember when she was talking about the hardware and the cycle, and when you first get that hardware, it's already old, right? But not only that, at the end of that 3-year cycle, then those vendors are going to come to you and they're going to start telling you what to do with your system in some way, shape, or form, by raising maintenance, by doing certain things that actually force behavior. So the decision making becomes theirs, not yours, as far as what you're going to do in your environment relative to your storage. This gives you complete power and control over that environment. You make the decisions about when you want to upgrade. The license from Nexenta is perpetual. Some of the other things that were pointed out that are completely free are free. So basically, it's up to you now to decide. Do I want this new feature? Do I want this faster processor? Do I need to upgrade? Or am I okay just running it for the next 2 or 3 years, even if it's out of warranty? It's entirely up to you. It's really about saving money, but more importantly, it's about putting the decisions around your storage back in your hands and not in the legacy storage vendor's hands.
Maybe one more question?
Okay. So is INgroove's, or for that matter, actual data, is it all spindle based?
So yes, at the moment we are mainly spindle based, especially for our storage need where we store music content. We don't need fast, super fast system. So it is a spindle based. Like right now, the 500 terabyte of usable storage space is spindle based. Even our virtualization system with 15K SAS drive.
You ever see that changing?
So later, if we, for example, go with running databases on it, because we are trying to really roll out software-defined storage in our environment, and databases are still running on legacy mesh system, where in this case we have other type of configuration with IBM XIV and SAS caching and all that comes with it.
Or Flax ever.
Oh yeah, whatever you want to run on. So.
Go ahead. I can tell you from our point of view, we really like the whole idea of the hybrid system, the tiered. So we're running on 7,200 RPM drives, and you go, well, that's too slow, but it's not, because we've got that L2 ARC, which is our SSD, and then we have the ARC, which is incredibly fast. That's our RAM. And my argument's going to be this. I have plenty of big databases. In fact, one of the main reasons we switched to Nexenta, we had originally bought the system to do file management, document management, and we started having this monster VM that was a SQL database just killing the I/O on our compelling system. So we're like, hey, maybe we'll just move it over to the Nexenta system and keep it from thrashing all the other VMs. It ran 3 times faster there, and then obviously we started putting everything on Nexenta because, again, we didn't trust them at first. But Let's look at a system like email. Everybody wants their email to run fast. They all have 10 gigs of email. You tell them to delete their emails, they're not going to do it. But what do they really need to run fast? They need to run fast the messages that just came in, that they're looking at. The messages that they've kept for 5 years don't need to run fast. Well, when you start talking about a pure flash-based system, you get to say, well, this VM runs fast and this VM doesn't run fast. You don't get to say, this email runs fast, that email doesn't. So the whole hybrid approach is that things that people are using are getting copied, and I think that's a big difference between some of the other mesh providers. Some mesh providers are every hour or once a night moving data to flash or blocks. ZFS copies it on the fly because my flash is not as dependable as my storage, as my spinning disk. So I don't want it moved, and you could lose the data when you're moving it or get corruption. I want to copy there, and if I lose my flash, I want there to be no problems with losing that. And I have critical VMs that need a whole ton of IOPS, and I make sure that I've got my ARC and everything working. But I would make the argument that that's when you need somebody like a Fusion IO or a bunch of these other players that put the flash close to the compute. And so that's what we're doing. We've got in each of our ESX hosts a solid-state drive that accelerates the databases. It's extremely affordable. It's much more affordable than trying to convert my entire, SAN.
But essentially it's a cache.
It's a cache.
And for those of you who might not be as familiar with ZFS, I know that we want to be observant of time, but we have a booth downstairs. We're happy to sit around and talk with you afterwards. If you have further questions, we can explain to you how ZFS caching works. It's a very, very cool thing. It really gives us the ability to actually leverage lower cost 7,200 RPM drives, but still outperform, in some cases, all flash arrays. So happy to talk to you about that.
Okay, we should probably wrap it up. We're a little over time. I'd like to just thank the rest of the folk at this table. Thank you so much.